So moving right along with isotopes, and here was where I was. Now, we talk about the average atomic mass, which is what you see on the periodic table. You look on the periodic table and you see that carbon has an average atomic mass of 12.011. Now, if the atomic mass is the protons plus neutrons, how in the world do you get a decimal? Well, that's because the atomic mass on the periodic table is really not just one isotope. You may have multiple isotopes. Like I said, carbon has 9 isotopes, so obviously there's going to be some averaging. Now, if I said that you had exactly the same amount, 33.33% of each of these, then your average would be 13, and we'd have an average atomic mass of the carbon 12, 13, and 14 as 13. Well, that's not the case in terms of isotopes for most atoms. They're not going to have exactly the same amount of each of them. So what we're looking at is, because we may have a larger abundance, a higher percentage of one versus the other, then that brings the average closer to that isotope. And I always use the analogy of, let's say you had a 100 on a test and a 50 on a test, okay? If you have the same amount, let's say you have one of each, one 100 and one 50, well, yes, your average is right in the middle of that, okay? But what happens if you have this many? You have 5 100s and 150. You've still got the same exact numbers. You have 5 100s and 150, but your average certainly would not be a 75. You're going to be a lot closer to that 100 because you have more of them. You didn't change the amount. You didn't change the fact that the number is different. It's not like you have a 100 and a 99 and 98, all that stuff. You've got just 100 and 50s. You have more 100s than you do 50s, so the average is going to be closer. If I have my calculator right here, if I have 550 divided by 6, I pressed the wrong button, 550 divided by 6, you get 91.7. So notice your average is a lot closer to 100. And I'm sure that you would want me, if I average your grades, that you have 5 100s and 150, that I wouldn't say that you have 75. Okay? So because you have a larger amount, more 100s, you're going to be closer than that. So that's exactly what we take a look at when we do percent abundance from the, or the average atomic mass from the percent abundance. Let me show you mathematically kind of what we're doing when we find the average between 100 and 50. If I take that 100, well, let's say I have exactly 50% of it. Okay, so notice I'm talking now about percent abundance. Notice I have one of each. One 100, 150, and so I have one of each, which of course would be 50% of each. If I take my number, 100, times 50%, of course I'm changing it to a decimal, and I add that to my other number, 50 times the percentage, in this case it's also 50, so 50%. If I add those two percentages times the number, notice that it's going to give me my average. 100 times 50%, of course, is 50. Add that to 50% of 50, which is 25. Notice that adds up to 75, which makes sense when you have exactly the same amount. So when you have different percent abundances, then you're going to do the exact same thing, except for you use different numbers than 50, let's say. So let's say I have 90% of carbon 12, 5% of carbon 13, and 5% of carbon 14. Let's do that math. I take my carbon 12, multiply it by 90%, add that to 13 times 5%, and add that to carbon 14 times 5%. Let me do the math on those. I've got 10.8 plus 0.65 plus 0.7. I add those three numbers up and I get 12.15. Notice that my average atomic mass in this case, because I have such a larger percent, 90%, this number is so much more closer to 12 than it is just smack dab in the middle. So that's how you do the average atomic mass from your percent abundances.